Okay, hello Algebra 2 students. For this one, the week of 6-1, June 1st, Algebra 2, we're doing rational functions. We're not, we did graphing earlier, so um, now, we're going to be doing operations, adding, subtracting, multiplying, dividing, and even a solving problem, okay? So there's 5 types of problems really I want to go over, and I want to do those now. 5 is pretty heavy. It's going to last quite some time, so I'm going to do this in one video. It's going to be a longer video, maybe closer to like 30 minutes or so, okay? But I'll try to keep it just to one video. And then the homework, as always, will be on the back side. This Friday, you'll have a test on this topic. Wednesday, I'll give you guys a practice test, and Thursday, for all Algebra 2 classes, will be the tutoring session, as always. It will be at 2 p.m. this week on Thursday. Okay? So, first problem I want to put up here is, let's do a multiplying problem. Okay? So we have up here x squared minus x minus 20. Okay, and then we have x squared minus 2x minus 15. Simply x squared minus 9. That should be good. Alarm bell should go off for that one. And then plus 5x plus 4. Okay, so if you look at these all are done purposefully. Okay, these quadratics that are here are all done purposely because they're pretty much all factorable. I mean, they are all factorable in this case. Okay, so you would be crazy to try to multiply all this right now, and that's not what you expected to do. So before we do anything, okay, and you know with multiplying, you don't remember the keep, change, flip. That's for dividing when you're dividing fractions. For multiplying, you just keep them the way they are. All right. So first things first, I'm gonna do a bunch of exercises. Okay? All right. 1 times negative 20, that's negative 20, or diamond method, whatever you want to call it, and the b is negative 1. Multiplies to that, adds up to that. So I know it has to do with 5 and 4, and it's going to have to be negative 5. Okay, and I'm going to ask myself, do I need to divide this by the a? Well, a is 1, it doesn't matter. Okay, so here it is, we got it. We're going to write it in factor form now. That's going to be x minus 5 and x plus 4. Remember, I'm not asking for the roots or the solutions. If I was, it would be x equals 5, x equals negative 4. Just rewriting it in factor form. Okay? So that first one is done. Now, down here, that one. Real quick. We got this one. All right. A times c is negative 15. Our b is negative 2. Multiplies to that. Multiplies to 15 is 5 times 3. Negative must be 5. And once again, our a is 1, so technically we're dividing these by 1, but when you divide these by 1, nothing happens, nothing changes. It just stays negative 5 and 3. So I'm going to write that as x minus 5, x plus 3. Simple. Let's move to this guy. Now this guy, I don't need to do a next method. I know this is a difference of squares. That should pop out to you immediately. So what is it, a difference of squares? It's going to be x plus 3, x minus 3, because that's x squared minus 9. If it was x squared minus 25, you would say 5 and negative 5. X squared minus 49, 7, negative 7, and so on. All right, last one, that one right there. All right, let's try this out. Up here is going to be 4, down here is going to be 5. Multiplies to 4, adds up to 5, 4 times 1. That one's easy. So x, and again, you could put 1 and 4. It doesn't matter the order. Okay. What was the point of that? Well, if you see it already. You can start again. I'm going to when we say this, but canceling it out from top to bottom. Okay. So let's do this. Let's cancel out x minus 5s. What else can we cancel out here? An x plus 4 up here and an x plus 4 down here. You can cancel out anything top to bottom because this is like considered one big expression here. And then what else do I got? Oh, I can cancel out an x plus 3 here, down here, and up here. So that's it. Looks like that's all I can cancel out. So my final answer is going to be x minus 3. I mean, there's nothing left over there. It's just 1. Over x plus 1. And that's our final answer when you multiply these two fractions. Okay? All right. Let's do a division problem. And I'll be honest with you guys, division problem is the same thing. Division is the same thing as multiplying. Just remember, keep, change, flip. So if you remember, if I told you guys, oh, what's 2 over 5? Let's give an example. 2 over 5 times 1 over 3. Simple. 2 times 1 is 2. 5 times 3 is 15. Done. But if I told you 2 over 5 divided by 1 over 3, well, first, before you do it, you have to do 2 over, you have to change this to keep, change, flip. And you guys remember doing that? Keep, change, flip. Okay, it's a little trick you learn, like in elementary school. Now, 2 times 3 is 6. 5 times 1 is 5. Okay, so that answer is different there. Okay, so just remember for division, you have to do keep, change, flip. All right, so let's get our problem out here, and our problem for division is x squared plus 5x plus 6 over x squared minus 5x minus 14 divided by 2x squared. So that one's a little more tricky. Just factoring it would be a little more tricky. And this one's going to be x squared plus 6x minus 7. Okay, so look at these. The a's are 1, 1, 1. This one's a 2, so just be careful. This one, x method or diamond methoding that, it's going to be just to have one extra step. All right, keep, change, flip. Yeah, exactly. So what I'm going to do is I'm going to rewrite this whole thing by keep, change, flip. I'm going to keep the first fraction. Some students are like, oh, I'll do that later. No, it's better to do it right off the bat. Change, and then flip this. So I'm going to have x squared plus 6x minus 7 on top, and then 2x squared minus x minus 3 on the bottom. All right, so let's see what happens. So obviously we're going to have to do a lot of factoring here. So let's start off with this guy right here, factoring. 6, 5 adds up, multiplies to 5, adds up to 6. That's going to be multiplies to 6. Oh, that would have to be, I drew a blank. 2 and 3. 2 times 3 is 6. 2 plus 3 is 5. So 2 and 3. X plus 3. Beautiful. Now let's do this one right here. Let me get my eraser. Do I have my eraser? I don't know where my... Oh, here it is. I don't have to get my fingers really dirty. Okay, so that's going to be negative 14. A times C is negative 14, and then B is negative 5. All right, we'll multiply to those, 2 and 7, but then 7 must be negative. That is correct. X plus 2, x minus 7. Looks good. Next. All right, let's do this guy right over here. A times C is negative 7. B is 6. Now you may be saying, oh, I always do A times C. It's always just this number, right? Well, watch out for this last one, okay? All right, 7 times 1, and the negative is to the 1. Yeah. Again, I'm doing this fast. It may take you longer to do these X methods, but that's fine. Take your time, okay? X plus 7, and then X minus 1. Okay, last, and you can, wait a minute. Wait a minute. Did I do this right? I may not have. Oh, okay. No. I did not do this one right. This one was supposed to be a minus 6x. I apologize. This was supposed to be a minus 6x. I apologize. That's supposed to be a negative 6. Sorry. So what this was supposed to be is negative 7 positive 1. I wrote that one wrong. Okay? Negative 7 positive 1. Okay, I wrote the question wrong. I apologize. Okay? No big deal. I just factored that, so I just changed the problem and turned it to that. Last one, I need to do this now. I want you guys to pay close attention when it comes to factoring this one. When it comes to factoring this one, we have to do A times C as always, but that's negative 6. And then the B is negative 1. What multiplies to that, adds up to that? Well, it's going to have to be a combination of 3 and 2. The 3 is negative. But in all the other cases that we have done, the A has always been 1. In this case, the A is 2. You must divide by the A. If it's 1, it doesn't really matter. Positive 1 doesn't really matter. But now we must divide by that A. That's going to give us that, and 2 over 2 is just going to equal to 1. Okay? So how do we write this out? First, use the denominator. That's going to be a 2, so that's 2x minus 3. Again, this is review of algebra and algebra 2. And then this is just 1, so that's just x plus 1. Okay, now let's take a look at this and see, is there anything we can cancel out? Well, obviously, x plus 1, x plus 1. I'm sorry, x plus 2, x plus 2. X plus 1, x plus 1. X minus 7, x minus 7. So our final answer, we're left with on top here just x plus 3. And on the denominator, we're just left with 2x minus 3. And that's it. Can't do anything else. We already did it. Okay? So now let's move on. We're going to move on. That was multiplying, dividing. We show multiplying, dividing first because that's easier. Adding, subtracting fractions is not as easy. So, quick reminder. When you want to come up with common denominators, there's one method that always works. Okay? Not necessarily always the best method, but one method that always works. Let's say you want to find a common denominator. You can't just add these right now. You just can't. The denominators must be the same when you're adding and subtracting. So one easy method is multiply top and bottom this fraction by the numerator, denominator there by 5. And multiply these two guys by this one's denominator, which is 3. So that's going to give us, look, magic, 5 over 15 plus 6 over 15. Guess what? We now have common denominators, which is 15. And you just add the numerators. That's going to be 11 over 15. You always have to double check to see if you can simplify that. You can't. Done. Boom. That also works with rational functions too. Okay, it works with pretty much everything. Okay, so let's try this out now. Again, it's not the easiest thing in the world, but let's try it out. What if I gave you something like this: 3 over n plus 5 plus 1 over n squared minus 25. Okay. Now you may be saying, whoa, this is not what I signed up for. This is a lot more hardcore. So yes, and you're absolutely right. But let's take a look at this. N squared minus 25, that should ring, red alarm should go off. That can be rewritten as n plus 5 and minus 5. And I want you guys to notice something. This already has an n plus 5. This guy already has an n plus 5. So how do I make these two common denominators? They're almost there. This has an n plus 5 and minus 5. This one has an n plus 5. It's just missing the n minus 5. So here's what we're going to do. We're going to touch that guy. That right hand, this fraction right here, 1 over n squared minus 25. We're not going to touch it. We don't need to. Only thing we need to do is multiply this left-hand one by n minus 5, because that's the only thing that's missing. Once I multiply it by n minus 5, guess what? They're going to have common denominators. So let's work this out. What's that going to be? That's going to be 3n minus 15 over n plus 5, n minus 5. Now, if you're wondering why I'm not multiplying this out, we know it's n squared minus 25. We factored it out. I'm just going to leave it at that for now. Okay? We haven't changed this fraction at all, so it's just 1 over the same thing, n plus 5, n minus 5. Voila, we have common denominators. So what can we do? 1 second, let me just write the denominator, the common denominator, n plus 5, n minus 5, and we'll just add these up. Now, please be careful. When you're adding, you have to add this entire thing. So this is going to be 3n minus 15 plus this entire quantity here, which is just 1. So that's going to be 3n minus 14. Okay? Now, you may not see your final answer like this. The only reason being is, yeah, this is the answer, but this is 3n minus 14 over n plus 5 and minus 5. Another way of writing this is 3n minus 14 over multiplied out. So n plus 5 and minus 5 is the same as n squared minus 25. So keep that in mind, okay? So either one of these are the correct answer. It just matters how you see it on the test, what it's going to show you. Okay? That was adding one. Subtracting, same thing, just subtracting, that's it. Okay, but I'm going to give you guys, actually no, I'm not going to give you guys a subtracting problem. Subtracting would literally be the same thing, except guess what? This is minus, this is minus, this is minus, and so this was a subtraction problem. It would be 3n minus 15 minus 1, which would be 3n minus 6. And then that would be your final answer. But the process for adding and subtracting, same thing, common denominator, okay? All right, moving on now. We're now going to move to division problem, but it's going to look a little bit different, okay? These last two, I admit, are going to be a little more on the tough side. But yeah, anyways, let's get to it. Okay. X over 2 plus 1 all over 3 over x plus 1. So you're dividing these two, okay? Now this is going to be a little bit more complex, but we'll do it. The first thing I want to do is I want to add these two. Okay, so first step I want to do x over 2 plus 1. Well, I want to make 1 a fraction just to make my life easier. I'm just going to say 1 over 1. All right? Remember, multiply this fraction by that denominator, multiply this by that denominator. Now, you may already know, if I multiply this by 1, it's not going to change anything. That's still x over 2. But if I multiply this by 2, that's going to get us 2 over 2. Well, what does that equal to? That's going to be x plus 2 all over just 2. You got it, okay? So I'm going to rewrite this over here. X plus 2 all over 2. Okay, now let's do this fraction. Now I'm going to rewrite this one right here, 3 over x plus 1. Now, let's think about this for a second. What does a fraction symbol really mean? A fraction symbol really means divide. So what I'm going to do is I'm going to rewrite this in a way that's a little more familiar. Instead of writing it as x plus 2 over 2 over 3 over x plus 1, I'm going to write it as a division problem. Divided by 3 over x plus 1. Now, and you know, based off the second problem we did, division is keep, change, flip. Let's do it. Keep, change, flip. And now it's just a matter of multiplying. Now, I don't see anything top and bottom that I can cancel out. Okay? Remember, x plus 2 is an entire quantity. X plus 1 is an entire quantity. You'd have to have exactly an x plus 2 down here, or an x plus 2 down here. You'd have to have an x plus 1 down here or down here. You know what I mean? We just don't have that. So there's nothing to really cancel out. So I'm just going to do times 3 is 6. And on top here is going to be x plus 2 times x plus 1. That one requires a little bit of multiplying, but I'm just going to fast forward it. That's going to, if you multiply it, that will give you x squared plus 3x plus 2. I know I'm squeezing it here a little bit, but just letting you know, x plus 2 times x plus 1, I'm doing the multiplying for you, is going to end up being x squared plus 3x plus 2, and then 2 times 3 is just 6. Okay? All right, I know that's a lot. We still have one more, and this is the hardest one we have we haven't done yet. Okay, the solving problem. Okay, it's gonna be heavy. I know it's gonna be heavy. Trying to squeeze it into the least amount of time as you possibly can. Okay, so here's a solving. Prefacing it, this will be a little heavy. Just follow along best you can. 50 over y minus 50 over y minus 2. Is equal to, let me make sure I'm getting it right. Okay, it's equal to 4 over y. All right. So the solving problem, where we know that is because it says it has an equal sign, and it's going to tell you to solve, most likely. All right. So we need to subtract these two fractions. Well, okay. Well, what can I multiply to these to make them common denominator? I need to multiply something to make them common denominator. Well, okay, I can do the old tried and true method where I multiply this fraction by that one, y minus 2, by y minus 2, and I multiply these two by this guy, this denominator, which is y. Let's see what happens. That's going to give us the top right here. 50 times y minus 2 is going to be 50y minus 100 over y times y minus 2 is y squared minus 2y. Cool. Minus. Let's look up here now. 50 times y is 50y. Over. Well, this y minus 2 times y has to give me the same thing, because the whole point is to get common denominator. It's going to be y times y is y squared. Negative 2 times y is negative 2y. That's how you know you did it right. You're going to have the same denominator. All equals 4 over y. Okay, let's continue this. We have common denominator. We can now subtract this problem. Add or subtract in this case. In this case, it's asking to subtract. So let's do this. That's 50y minus 100 minus this whole thing, which is 50y. All over, what is it? Y squared minus 2y. Huh. Equals 4 over y. My arm's starting to hurt. Okay, let's do this now. 50y minus 100 minus 50y. Well, yeah, okay, thank you. 50y minus 50y. Cha-ching. 50y minus 50y. I'm left with that. Here's the key now. I have two fractions equal to each other. What do I do to solve two fractions equal to each other? The example, see if you guys can figure this out. If I have x over 2 equals 5 over 1, and I said solve that, simple. X cross multiply. X times 1 is x. 2 times 5 is 10. You got your answer. What if I had x over 3 equals that? No, same problem, sorry. Equals, sorry, x over 3 equals, I don't know, something like that. Multiply those, cross multiply, 2x, multiply these, 21, divided by 2, divided by 2, we got our answer, x equals 21 over 2. All right, that's fine. Cross multiply is what I'm trying to get across. So let's do the cross multiply one then. Negative 100 times y is negative 100y equals this times this. So that's going to be 4 times that. That's going to be 4y squared. 4 times negative 2y is negative 8y. If you look at this, this is looking kind of familiar. What I'm going to do now is I'm going to combine like terms. I'm going to move that negative 100y over to this side and see what happens. So I'm going to go plus 100y plus 100y. That's going to get me 0 equals 4y squared plus 92y. Okay, moving on now. 0 equals, they have something in common here. What do they have in common? I could factor out a 4 and a y. So that's going to leave me with y plus, okay, how many times does 4 go into 92? That's 23 times. Whew, that's a heavy problem. We're not done yet. Zero product property. So 4y times y plus 23 equals that. So zero product property. 0 equals 4y. Can you guess what y is? Simple. Divided by 4, divided by 4, y equals 0. Here's one answer. Let's do the second answer. I'm going to cover this up. Ready? Y plus 23 equals 0. Minus 23, minus 23, y equals negative 23. That is heavy. I know. That is extremely like, whoa, what the hell? You just did all that? Yeah, I know. Okay. But it will be kind of shifted. Like you won't have as many of these difficult ones, maybe like one of those, you know what I mean? But you'll have more of the multiplying, dividing ones, maybe a couple of the adding, subtracting ones, okay? So it will be kind of leveraged that way too. So don't trip out too much if you don't understand this right off the bat. This problem alone on a regular school environment would probably take us days of just kind of showing you at least one every single day, just so you guys can start getting the hang of it. So don't worry if you don't understand this. These last two were a little more heavy, okay? All right, so let's put this over. Okay, here are the homework questions. And again, what I want to point out to you guys is this. Really need you guys to be able to know how to do that one and that one. They're related to one another. This one's also pretty important. These last two, 4 and 5, are going to be a little more difficult. Try them, okay? Don't be too intimidated. Try, especially number 5. Number 5 is a heavy one. Try them. Don't be too intimidated. If a lot of students will probably get those two wrong the first time around they try it, but it's okay. All right. If you get the tutoring session, we can go over it. But 1, 2, and 3 probably the most important ones. All right. Thanks, guys. And again, our tutoring session is going to be Thursday at 2 to m. Zoom.